Why is it b divided by 2 squared? So we have a 9 here. Thanks, Frank. Can I have your pass? Thanks. Odette?
Because you want the square root of b to be to itself.
Okay, that makes sense. And I'm going to show you visually as well why it works. So we took b, which is -6, divided by 2 squared. All right, and that was 9. And then it says to factor the left side as a perfect square. Notice that this is now a perfect square. Anytime you square something, it's a perfect square. So the two numbers that multiply to be 9 are 3 and 3. And it's a negative because we're trying to add to be -6. The reason you take b divided by 2 is because anytime you factor, there are 2 parentheses. That number is double. So it's a perfect square. I'm going to be using that double, those same 2 numbers, twice. So I double it to get the middle number, but I square it to get the outside number. So that's why you're taking it and cutting it in half, because you're really then doubling it when you're writing it twice. And this is now equal to 9. So instead of writing it like x minus 3 times x minus 3, because this is the only time I'll write it like that, how would you really write that, Quinn?
Isn't that one side equal to 13?
Yeah, because I didn't add. Thanks. How would you write that, Quinn? X minus 3 times x minus 3.
Oh, x minus 3 squared.
Yeah, x minus 3 squared. We will be jumping from this step, the first step, to that step. We won't write them twice, but they really are there. It's doubled. And then that would be equal to 13, not 9. So this step here is the end of step 3. And that means the process of completing the square is done. So the goal of completing the square is to get a quantity that is squared. On Friday, we'll be graphing this parabola as it's listed, because then I can get pieces of the parabola based off of the way the graph shifts, because we did all that translating. All of chapter 1, we translated graphs. How does it move left, right, up, down, stretch, vertically, shrink, vertically. So we're going to be doing that with a parabola now. Jacob.
So you don't need to do anything else left?
Well, this problem asks us to solve, so I've completed the square, but the directions say to solve. So we do need to go further. Anytime you solve, what are you finding when you solve besides x? What does it really mean? Graphically, if you're finding x, what does that mean graphically? X-intercepts. So when you see the word solve, graphically, we're finding the x-intercepts. So you're finding x, but correlating with the graph, it's the x-intercepts. Jacob, how would you solve when you have something squared?
So you take the square root of the sides.
Yeah, take the square root of both sides. That's called undoing. So you're undoing the quantity that's squared, you're canceling it out. The square root of 13 is just the square root of 13, but plus or minus. Anytime you put the square root in the problem. And then finally, x is adding 3 to the other side, plus or minus, and then the square root of 13. The whole number, or the integer, is actually the more important number. It needs to be written first. Then the plus or minus sign, and the irrational number second. There really isn't a way to write numbers, just like variables. You usually write them in alphabetical order, or in order by their powers. So the second one underneath, the goal is for you to just practice it one more time to get a little more comfortable with the process. This one actually is factorable, so if it's factorable, you'll get nice answers. If it's not factorable, you're going to have radical answers in the problem. Never a decimal unless it says 2. Round to 2 decimal places, and then that means you have to get a decimal. Otherwise, you're going to keep it exact. So the first step, take that 8 to the other side by adding it since it is negative. And then b divided by 2. So Taylor, 2 divided by 2 squared. So adding 1. And then factor it. And again, go directly to that quantity squared, because it's going to be the same number. So Taylor, how does it factor? What times what makes 1? 1.
Sorry.
That's all right. So completing the square, that part is done. I goal. If I'm completing the square, I should have an answer that's squared, quantity. And then to solve it, we just take the square root of both sides to get rid of the square, so that now we can get x by itself. Square root of 9 is plus or minus 3, so your two values for x are
2 and 4.
2 and
4.
what kind of 4?
Negative.
And negative. Questions? Good?
Do you have to check to do you have to plug it back in the equation?
You can always check it by plugging it back in to make sure it's correct. There will never be any extraneous solutions though, because it's a parabola and x can be anything. So you can always check to make sure that it is equal to 0 by plugging that back in. Or you can check on your calculator as well. You could put the original equation in the y equals and check it. So there, like any equation that you solve for can always be checked. So if you flip it over, these are the fun problems. At the top of your page, it says some modifications need to be made if there is an A value.
Will this be our test tomorrow?
Only yours.
Okay.
I would do that. Maybe. So if there's an A value, why didn't the other two have A values? What was the A value in the other two? 1. When it's 1, it's easy. Even with factoring, when it's 1, it's easy. Because once there's an A value, then you have to do factor by grouping, and it's like 2 extra steps. If the A value isn't there, then it's just basic factoring, basic completing the square. So these say, your directions at the top says a modification needs to be made if there's an A value. Take notice though, the other side has that C value, so this original problem could have said x squared minus 6x minus 11 equals 0. We still have to take C to the other side first. But what modification do you think you need to make if there's an A value? Boy, Jacob, you're full of answers today, huh? Yeah?
You would, I'm having a brain for it. Like, I know what
Oh
I mean.
man.
So, you would take the 2x and put it outside of it.
Not the x, just the 2. So we're going to take the coefficient that's in front of x squared. Only the coefficient, because our goal is to keep x squared so that we can factor it. So whatever the coefficient with x squared is, we're going to take it out and place it outside of the parentheses. Now, the hardest thing for you to remember is no, you're not dividing it out. You're not getting rid of it. Because that 2 in my graph is a vertical stretch. And if I get rid of it completely, then I just have regular parabola. That doesn't have a vertical stretch. Jacob.
How would you say what I just said?
What?
How would you, like...
Oh, you just say you factor out the coefficient in front of the x squared. Easy enough. Alright, so we took out a 2 by factoring out the coefficient, whatever's with x squared. It has to be a 1 in order to complete the square. The next step is still to take b and divide it by 2. But you're using this b, not the b that we initially had. Because we took out the 2, we're using the numbers after we took out or factored the 2. So we have a negative 3. We're dividing that by 2, and we're squaring it. Now here's where I want you to get out of the habit of directly going to this thing here, which is almost as your best friend compared to this thing here. These guys are like your lifelines. Your best friend really should be somebody sitting in your class, but not your phone. Maybe not Kevin, but no. Yeah, no. Yeah. So, how do you square a fraction by using your brain and not the calculator? Connor.
Square the top and bottom.
Square the top and bottom. It's that easy. It actually takes you longer to plug it in your calculator and then hit math wrap to get it back into a fraction compared to squaring the top, which is 9, and the bottom, which is 4. Fraction has a top and a bottom. Treat them separately. Do the same thing to both. Just like an equation has a left and a right, do the same thing to both. Now, here's the question. What number do you place on the other side? Because it isn't 9/4. Because it has to 18 fourths. Right. Anything in parentheses here is really affected by that factor of 2 that we took out. Even though this 9/4 wasn't originally there, it is now because I used the numbers inside parentheses to get 9/4. So when we put that number on the other side, we have to double it. We've got to multiply it by 2. Again, when you multiply a fraction by 2, you're multiplying the top by 2. That's how she got 18. The bottom, really there's a 2 over 1, so that 4 stays on the bottom. So 2 goes to the top, the 1 goes to the bottom. Odette, can you reduce 18/4? Okay, that's a mixed number. I just want the fraction reduced. Divide both by 2. There you go, 9/2. So 2 times 9/4 is really 9/2. That's the number that goes on the other side. Because then it's equivalent to the same number that we have on the right. Mackenzie.
Would you subtract it?
It's always being added. Because I'm adding it here, we have to do the same thing over there. The only way it would become subtraction, Mackenzie, if we factored out a negative 2. So if we had a negative out there, then it would be a negative on the other side. Jacob.
If you combine it to 31/2.
Yeah, look at you, Jacob. How'd you get that?
11 times 2.
Yeah, so 11 is really 22 halves. Getting a common denominator, he said you'd combine that to be 31 halves. So 11 is 22 halves. It's the same thing, but we need a common denominator. Your homework last night had some fractions in it, especially the back page. I think there were a couple that had some fractions on it as well. So the last thing we need to do to get this to be completed with the square part is to figure out how this factors. So I know it has to be an x. If this is a minus sign, this has to be a minus sign. In the other 2 problems we did, we asked ourselves what 2 numbers multiply together, in this case to be 9/4. In the other case, it was to be 1, or this one here was to be 9. I need the same 2 numbers that multiply together. So that's 3 and 3, that was 1 and 1. What 2 numbers multiply together to be 9/4, Kevin? 3 halves. This right here is written somewhere on my board. It's the b divided by 2 value. That's every single time because you're taking the middle number and cutting it in half and squaring it to get 9/4. So if I go back to that middle number and cut it in half prior to squaring it, that's how it factors. Because 3 halves times 3 halves is 9/4. It'll always be b divided by 2 in your factor form. Questions? So at this point we've completed the square. But it says to solve, so now we're going to see if we can talk about solving this. So how would you actually solve for x? How would you get x by itself? 9.
You can multiply both sides by 2.
You're so close. Yeah, that's it. So instead of dividing by 2, once we have fractions, we think about multiplying by the reciprocal. So instead of dividing by 2, because I have a fraction on the other side already, we can multiply by 1/2. It's really the same as dividing by 2, but we've got fractions already to work with. So x minus 3 halves, multiply across, top times top, bottom times bottom. So just going across the top, across the bottom. And then take the square root. Just like we did before on the other 2 problems. When you take a square root of a fraction, Kevin, what do?
You square top and bottom.
Yeah, you square root the top and you square root the bottom. Most cases, that bottom number is going to be nice so that you can take the square root of it. Don't forget the plus or minus. Just because it was a fraction, it still gets a plus or minus. So adding the 3 halves, the plus or minus, and then the square root of 31 over 2. That is an honors problem.
I did that.
So if you feel pretty comfortable with those wonderful fractions, then you'll love trig.
Oh.
Kevin.
Could you write the answer x equals 3 plus or minus square root of 31 over 2?
You could because they have a common denominator. However, numbers are, this sounds stupid, but numbers are really picky. And a radical number and a integer, they don't like to mix. So they really do like to be separate. It's called the standard form of writing a number. So in your mind, you're thinking, yeah, but it's more simplified to have them together. But the numbers are saying, hey, we don't like to be mixed together in the same section. Other questions? All right, so the last one here. Solve 2x squared minus 10x plus 6. We're actually not going to solve this. We're going to stop with completing the square part. So before you think, oh, they're all divisible by 2. Yes, they're all divisible by 2. But if I do that, I change the shape and the location of the graph. So we have to be thinking of the graph and how it affects the graph. So instead, we need to take this 6 to the other side. That C needs to be moved. Don't touch it, just move it. Don't divide it by something, move it to the other side. So that's going to shift our graph up or down. That's going to be the piece that moves our graph. In the same step, looking at the two numbers that are left, if there's a coefficient with x squared, then we'll also take that out. It's a 2 again, so we'll pull that out. So if there's an odd number inside, you're probably going to have a fraction to work with because we're dividing that by 2. So negative 5 divided by 2 squared. Square the top, square the bottom. So the top squared is 25, the bottom squared is 4. And then you're multiplying that by 2. So the top becomes 50, the bottom is still 4. What is 50 fourths? Reduce to
25 halves.
25 halves. Jacob, what does negative 6 become so that it has a common denominator of a 2? Negative 12. So negative 12 divided by 2 is the same thing as negative 6, but it has a common denominator, so we can add it with 25. And then the last thing, we need that quantity in the parentheses. So what would go inside the parentheses?
Negative 5 halves.
Yeah.
Or x
X
minus.
minus 5 halves. And again, that number right over there, b divided by 2, because 5 halves times 5 halves makes my 25 fourths. Or if I add 5 halves and 5 halves together, I get 10 halves, which is 5. Questions? So the next page in that chapter 2 packet, there are problems asking you to complete the square and to solve. So like you would go through the whole process of solving. Those are due on Friday. So no, it's not on your test tomorrow. No, I won't be looking at those tomorrow because when you walk in, I'm going to give you your test tomorrow. So they're due on Friday. The answers were sent this morning through Remind and also posted to Google Classroom, as well as the answers to both review worksheets. They were sent yesterday through Remind and posted to Google Classroom. On Google Classroom, the answers to this worksheet are under Chapter 2, since this is in Chapter 2, whereas the Chapter 1 review worksheets are under Chapter 1. So right now, it's up to you if you want to work on reviewing for tomorrow's test or you want to do this worksheet. Totally up to you. But I would like you to take out the Chapter 1 packet and turn to review worksheet number 1, because I'm going to come around and take a peek at it. So you can grab a partner, ask questions as I walk up to you and look at your packet. Whatever questions you have, I can answer. Questions? Test tomorrow is front, back, front, back. So it's 4 pages. I would say that's a typical test in here, front, back, front, back. About a half an hour. If you work a little slower, it might take you a little longer. That's usually, I gauge, about a half an hour work for a test to give some people extra time if